All right, so 7.3, the last thing that we need to talk about this semester. So we're going to talk about three variable systems. So what we've done with two variable systems is when we solve by elimination, we multiply our equations by some number that lets us, when we add them together, one of the variables goes away. So we end up with something like 3x minus 2y equals 10. I'm just making this up. And for our other equation, we end up with y equals 2. So we work with our equations so that when we add them together, the x goes away. This tells us that y equals 2, and that lets me substitute y back into the first equation and solve for x. So we can, what we call back substitute. When we get our equations in this form, where one of the variables is missing, and in the last row we just have x equals something, y equals something, we call this row, this is kind of a fancy word, we call this row echelon form. So when we get our equation in this form, where we can then substitute to solve for our variables, we call that row echelon form. So this is what it looks like in two variable system. With a three variable system, our goal is to get our equations to, this is just an example, to look some row echelon form to look like this: x minus y plus 2z equals 1, y plus z equals 3, and finally z equals 2. So for a three variable system, this would be our system in row echelon form. And what that means, what row echelon form means, is we have this kind of reverse stair step here. We have an x and a y and a z, all three of our variables in the first equation. We have the first variable, we have x missing in the second equation, and in the third equation we have x and y missing. So our goal when we're solving three variable systems is to get our system into row echelon form. What this lets us do is then I can substitute z into the second equation and solve for y. And then I could substitute y and z into the third equation and solve for x. So when we get our equations into row echelon form, in this kind of reverse stair step, that lets us substitute and solve for our variables. So our goal is to get our three variable system to look like this. And our solution, if we substituted z into this equation, we would find that y equals 1, and if we substituted y and z into the first equation, we would find that x equals negative 2. So our solution to this system turns out to be negative 2, 1, 2. So we get what we call an ordered triple rather than an ordered pair. So we get a point, rather than on the xy plane, we get a point in space. We have an x and a y and a z. So our solution is an ordered triple. And again, our goal with a three variable system is to transform it into row echelon form, so we can then use substitution to solve for our variables. What we're going to do to get our system into row echelon form is what we call row operations. I just want you to be familiar with these terms so when you see them in the book, when the problems ask you to do something, you'll understand what they mean. So our goal is to get our system into row echelon form. We're going to use row operations. These row operations don't change the solution of the system. All we're doing is doing operations on the equations that don't change the equations themselves. So our row operations are, we have three of them. We can switch the position of any two equations in our system. That doesn't change the solution of our system of equations. We're just switching the position of two equations in our system. The second row operation is multiply. And multiply, we could say, or divide, because division is essentially the same as multiplication. We can multiply or divide any equation by a number. And it can't be 0. We can't just multiply by 0. Because if we multiply by 0, then the entire equation goes away. So we can multiply or divide by any equation by a number. So we've done that on some of the examples that we worked on today. To get rid of decimals, we multiplied by 10 or by 100 or by 1,000. So we essentially were doing one of these row operations. And our third row operation is to add a multiple of one equation to another equation and replace the second one in the system. So I'm just going to say replace it. So that's what we did when we solved the 2 by 2 system, when we multiplied one equation by a number and added the two equations together, and we got y equals 7. That is what we were doing. That's what we were doing. That's this row operation. We replaced the second equation by y equals 7. So these are the things that we're going to do to our system of equations to get it into row echelon form. So we're just making what we did with 2 by 2 systems, making the rules a little more, we're just stating the rules up front. These are the things that we can do. We've already been doing it with 2 by 2 systems. Now we're going to do it to 3 by 3 systems, and we have to be a little more systematic about it, because what we end up doing is repeating these kinds of things, these steps, multiple times. So we don't just do it once and we're done. We usually have to do this several times to our system of equations before we get an answer. And this process of using row operations is called Gaussian elimination. So in the book, when it says use Gaussian elimination, what it's meaning is just use these row operations. And the name comes from Carl Friedrich Gauss is one of the most famous mathematicians of all time. And I think he may have been one of the first ones to come up with this process. Gauss did lots of different things in math and in physics. So we're using our row operations to get our system into row echelon form. That process is called Gaussian elimination. We've been doing this with 2 by 2 systems. We just didn't make the process quite as formal as we're doing here. So what I want to do is just do 2 examples of a 3x3 system, and then let you work on something. So any questions before we start? Okay, so let's do a couple of examples. And I'm going to write, when we do these examples, I'm going to write out a lot of steps. I'm going to write exactly what I'm doing, when I'm doing it. You won't necessarily have to write out quite as much detail as I do when I do these examples, but I just want to, as we do the examples, I want to list every little thing that I do so that we can see this process. So, we have x minus 3y plus 2z equals 1. 2x minus 5y plus z equals negative 5. And the last equation, 3x plus y minus 2z equals negative 1. So there's our system. And we are trying to solve for x, y, and z. Now our first step, when in row echelon form, we have our x, y, and z in the top row, and the number in front of x is a 1. So I don't need to do anything with this top row. So for the rest of the example, we're going to leave this top row alone. We might use it to do something else to the other rows, but this top row is going to stay exactly like it is, because this top row is fine for our row echelon form. Now I want to combine the first 2 rows to get rid of x. So what can I do to combine the first 2 rows to get rid of the x in the second row? Multiply the first equation by negative 2. So I'm going to multiply by negative 2, and I'm going to rewrite my system after I do that. So I'm going to multiply by negative 2. So I'm going to rewrite that over here. I'm going to say that if I multiply this by negative 2, I get negative 2x plus 6y minus 4z equals negative 2. And my second row, 2x minus 5y plus z equals negative 5. And I'm just working with these 2 rows. And I'm going to add these 2 together. So when I add these 2 together, my x's add together to equal 0. And I get 6y minus 5y is y. Minus 4z plus z is minus 3z. And that equals minus 2 minus 5 is minus 7. So I multiplied the first row by negative 2, and I added it to the second row. This equation is my new second row. So I multiplied the first equation by a number, added it to the second row, and now I'm going to replace the second row with this equation. That's one of the row operations that we're allowed to do. So now I'm going to rewrite my system here. X minus 3y plus 2z equals 1. I wanted to leave that row alone. This is my new second row. Y minus 3z equals negative 7. And my third row is 3x plus y minus 2z equals negative 1. So that's my new system. I just perform my row operation and replace my second row. So now I'm 2 steps into my row echelon form. I have an x here, and I've got rid of the x in the second row. Now I'm going to use the first row to get rid of the x in the third row. So what do I have to do? What do I have to do to this first equation to get rid of the x in the third row? Multiply by negative 3. So I'm going to do that one in blue. So I'm going to multiply by negative 3. And I'm going to rewrite those two equations over here. I get minus 3x plus 9y minus 6z equals negative 3. And I'm multiplying, and I'm going to add it to the third row. 3x plus y minus 2z equals negative 1. Add those together. When I add these, the x's add up to 0. 9y plus y is 10y. Minus 6z minus 2z is minus 8z. And minus 3 minus 1 equals negative 4. This is my new third row. So now I'm going to rewrite my system with my new third row. X minus 3y plus 2z equals 1. Y minus 3z equals negative 7. And 10y minus 8z equals negative 4. So there's my system after my second operation. Now I'm going to use the second and third row to get rid of the bottom row. So to get rid of the bottom row, to get rid of the y in the bottom row, what are we going to do to the second row? Multiply the second row by negative 10. I'm going to multiply this by negative 10, and I'm going to write that step over here. So what you can do as you do these is, if you can do this operation in your head, say I'm going to multiply this by 10 and add it to the third row. If you can do that without writing out all the parts, that's fine. It's really easy to make a mistake with a sign, an addition, subtraction error. So as much detail as you can keep in to keep yourself straight is a good idea. But if you do this a lot, you can say, okay, I'll multiply this by 10, add it to the third row, and figure it out. I'm just writing everything out here. So when I multiply the third row by negative 10, I get negative 10y plus 30z equals 70. And I'm going to add that to the third row. 10y minus 8z equals negative 4. Add those together. The y's go away. Add to 0. 30 minus 8 is 22z. 70 minus 4 is 66. And this is going to be my new fourth row. And I'm going to rewrite this over here, finally. And I'll have my system in row echelon form. X minus 3y plus 2z equals 1. Y minus 3z equals negative 7. And what else could I do to this before I rewrite it? Divide everything by 22, so this tells me that z equals 3. So this could be my new third row. So I'm going to rewrite that here. Z equals 3. So there's my system in row echelon form. Now I can substitute z into the second equation, and I figure out that y equals 2. And I can substitute y and z into the third equation and find that x equals 1. So my solution is the order triple 1, 2, 3. So nothing's difficult Nothing particularly difficult, just a lot of steps, a lot of details to keep track of. Questions on what we did here? Again, I want to re-emphasize, when we have a solution, this solution is going to make all three of the equations true at the same time. So if I plug this order triple into my original equation 1, 2, 3, each of the three equations should be true for my solution. So that if I plug that x, y, and z back into my original system, each of those equations should be true. All right, I want to talk quickly, really briefly, about what a system of three equations is telling us, and what the possible solutions are, and then we'll do one more example. So a system like we just had, let me go back really quickly. All of these three equations in 3 dimensions, those are equations of planes. So in 2 dimensions, if we have an x and a y, we have lines. These equations describe 3 different planes. So our solutions, there are a lot of different possibilities for our solutions. If we have a solution that we get an order triple, we get 1 point as a solution, that's like 3 planes coming together, like the wall, the 2 walls, and the floor come together at the very bottom corner of the room. So that bottom corner is our solution point, 1 point. Our 3 planes could come together kind of like a paddle wheel, and our solution could be a line. So that's when we get infinite solutions. Our 3 planes could be parallel to each other, and then we would get no solutions. We could end up with 3 planes that turn out to be the same plane, and we would get infinite solutions again. And we could also get 3 planes that intersect in kind of a triangle, and then we would get no solutions again. So there are lots of different possibilities for the intersection of those planes. But for a 3-variable system, their intersections are planes, and we have different possibilities for their intersections. All right, let's look at one more 3-variable system, and then I'll turn you guys loose on these. Okay, so this system, x plus 3y minus 2z.
Is this just like the one we just did?
Yes, essentially the same thing. Minus x minus 2y plus 6z equals negative 2, and 3x plus 11y plus 2z equals 6. So this is our system. So for row echelon form, our first equation is fine. We have no number in front of our x variable. So we just need to start getting rid of variables. So we're going to use the first 2 rows to get rid of the x in the second row. So this one's nice because we don't have to multiply by anything. We just have to add these 2. Add the first and second row. Add those 2. So my first row stays as x plus 3y minus 2z equals 1. When I add these 2 together, I get no x's. 3 minus 2 is y. Negative 2 plus 6 is plus 4z. And 1 minus 2 is minus 1. So that's my new second row. And my third row is still the same. Now I want to use the first and third rows to get rid of the x in the third row. So what do I need to do here? Multiply the first row by negative 3. So I'll rewrite those 2 rows. I get minus 3x minus 9y plus 6z equals negative 3. And I'm adding that to the third row, 3x plus 11y plus 2z equals 6. Add those two. This gives me 0. Minus 9 plus 11 is 2y plus 8z equals 3. Let's see, -3. Let me make sure I did everything right here. -3. Okay, so this is our new third row. I just making sure I didn't make any addition errors. So that's our new third row. So I'm going to rewrite our system. We have x plus 3y minus 2z equals 1. Y plus 4z equals -1. And 2y plus 8z equals 3. And now we're going to use the second and third rows to get rid of the y's. So what do we need to do? Multiply the second row by -2. I'll rewrite that over here. Minus 2y minus 8z equals 2. And 2y plus 8z equals 3. I add these together and I get 0 here, I get 0 here, I get 0 equals 5. What does that tell me? No solution. So we end up with no solution for this particular one. So as soon as we hit something like this, 0 equals 5, 1 equals 0, 10 equals 15, we know that we have no solution. So we can just stop. All right, questions on row operations and Gaussian elimination? Process is not hard. It can be a touch on the tedious side, but it's just multiplying and adding and subtracting. That's all we're doing, just doing it over and over and over. All right, so like I said, this is a lot of problems. Worked on some today. We'll finish up tomorrow. So our homework. Page 507. All right, there you go. Oh, see, it was under 30 minutes, Alex.